In this video, I'm going to show you how to solve equations that contain a radical in them. Now, when solving a radical equation, there are two important things to remember. One is at the beginning and one is at the end. So first, you want to identify any restrictions on the variable. And you do this by setting the expression underneath the radical symbol to be greater or equal to. Now, right here, I only have greater, so I'm going to put greater than or equal to 0. And then you want to solve for the variable in this little expression. Now, the second thing that you want to do at the very end is after you found your root or your solution, you want to check to see if that solution is extraneous. Remember, extraneous means that it actually does not satisfy the original question. So you do this by taking your solution, you're going to substitute it into the original equation to see if it satisfies the original equation. We're first going to take a look at equations with one radical term. So to solve these, you're first going to isolate the radical expression. So isolating the radical means that there's no coefficient, there's no number added extra outside of the radical. Okay. So once you've done this, now you can square both sides of the equation. So remember to distribute. Some of you might call this FOIL, okay? So remember to distribute if you are squaring a binomial. And you're going to solve for the variable and then check to see if you have any extraneous roots. All right, so let's go through these steps with an example. So first we're going to isolate the radical expression. So you can see in this example here, it's already isolated, okay? But actually before I do that, I'm actually going to check for my restrictions. So underneath my radical symbol, I have 5x plus 1. So I'm going to say that 5x plus 1, it has to be greater or equal to 0. So then I have 5x is greater or equal to negative 1. And then I'm going to divide both sides by 5. So x is greater or equal to negative 1/5. So first I already know that my solution has to be greater or equal to negative 1/5. All right, so my radical is isolated. So I can go to the second step, which is to square both sides of the equation. So I do that by just putting brackets around both sides. And remember, we're squaring the entire thing. Okay, so then next, when I square a square root, that makes that disappear because they're inverse operations. So I'm left with 5x plus 1 on the left side. And that equals 3 squared, which is equal to 9. So now I have something that's quite easy to solve. I know how to do this. Subtract 1 from both sides. I get 5x equals 8, and then divide both sides by 5, I get x equals 8/5. So now I'm going to check. So I'm going to write check here so that I know this is what I'm doing. I'm going to plug in my 8/5 in for x plus 1, and I want to make sure that it equals the right side, which is 3. So 5 times 8/5, the 5's cancel off. So then I have inside my radical 8 plus 1. So it's going to be root 9 equals 3. So yes, indeed, 3 does equal 3. And therefore, my solution is x equals 8/5. All right, let's take a look at the next one. It doesn't look as nice. Definitely the radical is not isolated. But again, before we do that, let's set my radicand to be greater or equal to 0. So I have 4 minus 3x greater or equal to 0. So then negative 3x is greater or equal to, I'm going to subtract 4 from both sides. So 0 minus 4 is negative 4. And then I'm going to divide both sides by negative 3. Now remember, when I divide by a negative number, I need to switch my inequality symbol. So now I'm going to have x is less than or equal to 4/3. All right, so this time I want my solutions to be less than or equal to 4/3. Okay. So let's go ahead and we're going to isolate the radical. So I have a negative 2 times the radical, and then I also have a minus 9. So I'm going to move the negative 9 first by adding 9 to both sides because we need to add and subtract first. To isolate. So adding 9 to the right, I then get 10. And then I'm going to divide both sides by negative 2. So I get square root of 4 minus 3x equals negative 5. Now I'm going to pause here for a sec because When I square root a number, I know that that number always has to be a positive value. But you'll see that when I square root this expression on the left, I should be getting -5, and that's actually impossible. Okay, so I'm going to actually write this down. So you cannot square root to get -5. Now, let's say that we didn't see that, and let's keep going and see what happens. Okay, so we're going to square both sides. So when I do that, I get 4 minus 3x equals positive 25 on the right. Subtract 4 from both sides. I get -3x equals 21. Divide both sides by -3, and x equals -7. So if I actually kept going, it does seem like I have a solution, and that solution is -7. Now let's do a check. So I'm going to take -2 times 4 minus 3 times -7 minus 9 on the outside equals 1. So let's simplify my radical first. So I have 4 minus 3 times -7. So that's going to be 4 plus 21. So it's 25 inside minus 9. And then I have -2 times the square root of 25, which is 5. So that's going to be -10 minus 9. So on the left side, I get -19. It's supposed to equal 1 on the right side, and it doesn't. So this does not equal, which means that x equals -7 is what we say or call an extraneous root. Now, this is what would happen if you actually went through and followed this all the way, okay? But if you do notice at the beginning, that when you square root 4 minus 3x, it equals -5, then you can stop. And then what you can then do is to then write in either sense or in either case, there is no solution to this question here. This last example that I want to do, I want to show you what happens when we need to square a binomial. So you'll see that here, the radical is already isolated. Okay, so let's identify our restrictions. So we have 2x squared over 3 plus 3, and that has to be greater or equal to 0. So then I get 2x squared over 3 has to be greater or equal to -3. Multiply both sides by 3, I get 2x squared greater or equal to -9, and then I divide by 2, x squared is greater or equal to -9 over 2. Now, what I should be doing in this instance here is actually to solve the inequality like we've done before in the previous chapter. However, I'm going to use a little bit of logic here. I know that no matter what number I pick for x, because I'm going to square it on this left side, this will always be greater or equal to -9 over 2. So therefore, there isn't actually any restriction here. So there is no restriction, which according to this means that x can be any real number. All right, however, I need to check something else, which I didn't talk about earlier. Now, when I square root anything, I know that I always have to get a positive value. So that means actually that on this right side, the x minus 1, that has to also be greater or equal to 0. Now, we only have to do this when there is also a variable on the right side. So if you look at the previous questions, we never had another variable on the right, so we didn't have to check those. However, in this example here, there is an x variable on the right side. So we're going to set x minus 1 to be greater or equal to 0. So now we also have to say that x is greater or equal to 1. So that actually will be a restriction. All right, so now let's go ahead and we're going to solve. So the radical is already isolated, so we're going to start by just then squaring both sides. Now, don't forget that when I square the right side, I am actually squaring a binomial. So on the left, I get 2x squared over 3 plus 3. But on the right, this actually means x minus 1 times x minus 1. Okay, so that means that I need to actually expand this. So let me rewrite my left side. On my right side, I get x squared minus 2x and plus 1. Okay, now I kind of don't want to have this fraction here, so I'm going to multiply all my terms through by 3. 3 because the LCD equals 3. Okay, so then I get 2x squared plus 9, because I multiply by 3, equals 3x squared minus 6x, and then plus 3. So I multiplied the left side by 3, and I'm multiplying the right side by 3. All right, so let's move everything to one side. I get 0 is equal to x squared minus 6x, and then move the 9 over, I get minus 6. Now this is not factorable, okay? I can't find two numbers that multiply to negative 6 and add to negative 6. So what I'm going to have to do is to use the quadratic formula. So I'm going to do that over here. So x is equal to negative b. So in this case, it's going to be negative 6. So it'll be positive 6 plus or minus the square root. And it'll be negative b squared. Sorry, not negative b squared. It'll be negative 6 all squared. Make sure you put that in brackets. And then minus 4 times a, which is 1, and then times c, which is negative 6. All of this will be over 2 times a, which in this case will be 2 times 1. So we have x is equal to 6 plus or minus. Simplifying my radical, I get 60 inside, all divided by 2. And I know that 4 goes into 60. So I'm going to simplify root 60 to be root 4 and root 15. So that will be 2 root 15 all over 2. And I can reduce, and I could only reduce these three numbers here. So all of them are divisible by 2. So I get 3 plus or minus the square root of 15. Okay, now 3 plus root 15, so just because I don't have the space to check, you can also check it on your calculator. You'll find that 3 plus root 15 works, but 3 minus root 15 is not going to work. And also it doesn't actually satisfy a restriction because 3 minus root 15 will be a negative number, and that is actually going to be less than 1, which is part of our restriction from back here. So 3 minus root 15 is extraneous. So therefore, our only solution is x is equal to 3 plus root 15. And that's it.